Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage, Glen Ellen, Illinois. And this video today is going to look at Day 8 of the Advent of Code 2020 festivities. I am, as always, so far writing all my code in Python. I did Day 1 in C++, but I have since moved on. Python is such a fun little language. I wonder if it's going to go anywhere, if it's just going to be bad. So anyway, handheld halting. You're writing a mini computer. We're simulating, we're virtualizing, we're doing whatever you want to call it. Right now there's 3 different operations. We can accumulate, we can jump, and we can no-op. And this is a time where I can say, hey, I have a whole series of videos on x86 assembly language and binary to hex and all the stuff you need to learn to make it all work. Why don't you go watch it if you really, if you want to see a little bit more about what the computer, the CPU is really doing, we're going to approximate that. This is like last year, then we're probably going to see maybe 5 or 6 or more of these things tied together these days. So I would say let's see what happens on day 10 to see if we have to advance day 8. Anyway, so yes, so what I did first here is I went and opened the text file. Do I have it open here right now today? Yep, I do. And here it goes, and it's a lot more complicated than the example shows, of course, numbers flying all over the place. And so the first part of this is to take that every line, convert it into, and I have it as a list, basically a list of lists. If you want to think of it that way. So all this code is for nothing here because it's not going to print the answer just yet. But you can see here, every operation is reduced into its name, or its operation name, its parameter, and then I appended a 0 for how many times that line of code has been executed. So that's the basics of what's going on here is to keep that 0 to go with it and say that's what I want when it comes to how many times I visited. And so everything else should be pretty simple here. There's only 3 operations right now. And so at any given moment in time, I say whatever operation, let's accumulate the accumulator, the number of visits. Let's add 1 to that. So for operations EIP at the second element, add 1. And if it's greater than or equal to 2, then break. Because the first time, this is at least for part 1 here, the first time you see one of the operations be performed twice, then you're done. And then whatever the accumulator is at that moment will be the answer to this puzzle. Otherwise, if it's no op, you just move the instruction pointer by 1 unit. That's just the array element, and the accumulator is the accumulator. If it's a jump, you just add whatever that number is, whether it's a positive or negative, you add it in, and it changes the instruction pointer. And otherwise, accumulator, you add to the accumulator, and you go down to the next line of code. And if you do all of this cool stuff, you will find that the answer is, lo and behold, 2034. So that's it. And so let's take a look now at part 2, and then guys, we can go on with our day and our marriage. Okay, and as always, not always, but always enough. As with part 1, part 2, we're just going to read the same file. We're going to start up everything. So everything up to here is just going to go away, but we do set up the file and set up our list of lists exactly the same for part 2. And again, this is not this is an hour in. I got it working. It's not the coolest looking code ever. I'm sure I can improve quite a few things, but I want to go to bed. So, and thank you for watching, whatever time you're watching, wherever you're watching in the world. So this time around, it's for part 2, it says one in that whole big file that we have here, one of these lines of code is wrong, and there's one little tiny error to fix up. One of the jumps is supposed to be a no-op, and one of the no-ops is supposed to be a jump. And we don't know which one. And so what it is we're basically going to go through every line and figure out which one it is, because the one program that does not find a loop is the one that I'm looking for. And so the code that we wrote prior is totally fine, because it's the second I find that I hit a line of code 2 or more times, I'm done. And I did not find a solution, and I break out. And that's where this is all coming down to. And so for every operation in my list of operations, if the 0th element is a jump, turn it into a no-op, and if it's a no-op, turn it into a jump, and then basically do what we did before. And this just resets everything so that for every time I go through this and I change one of the operations and I start from scratch to see if this program can load and run without looping, then everything is going to be set in place, because this op2, that's the number of visits. Remember, we have to replace that back to 0 every single time because we're simulating every single thing here. But otherwise, the code is very much similar here. While this is the, say, like, again, if I see something 2 or more times, that's one fallout. But if I get to this point at where the line number is greater than the length of the operations, because remember it said that it would, basically, if I had something, it said go, plus 200 or something, if it's outside the bounds of the program, basically you've escaped the program ends. So that's where the while loop comes in. But this code is very similar. The operations, again, this time and this time around I just added a Boolean for whether I found a solution or not, and I just presume it's true until I find the counter example. And then just to make sure everything's back on the up and up, I just repeat this code here so that the jump that became a no-op goes back to being a jump, so everything's put back to how it was, so that every line of code is where it's supposed to be, especially if I'm going to do this looping. And so to finish it all off, if I found a solution, how about I print out what the accumulator is? And this is what you're here for, right? This is what you're waiting for. And the answer is 670. And I can prove that right there. So, as always, it's been fun. I hope day 9 is, I would say for me this was rather easy. I'm not trying to flex or anything, just saying. But these things are supposed to get harder. Maybe they've made them easier. Maybe I'm just getting to be a slightly better programmer. I don't know. But I'm looking forward to day 9. Thanks as always for sticking with this. And if you really want to check up on this stuff, since you're virtualizing a computer and you've never looked at x86 assembly language, why don't you just jump into one of my videos on the other pages there. Have a good day, everybody. Take care. See you next time.